Japan, 4.5% obesity rate. The United States, 43%. That is nearly a 10 times difference, and I need you to really sit with that number for a second. Now, here's what the mainstream health world gets completely wrong about that statistic. They'll tell you it's genetics. They'll tell you it's portion sizes. They'll say Japanese people just have smaller appetites. But I've spent nearly 15 years in emergency medicine and metabolism research, and I can tell you that explanation is lazy, and it is keeping you overweight. Because if it were genetics, why do Japanese Americans who adopt a Western diet develop obesity at nearly the same rate as everyone else? Why do Okinawans, who traditionally have the world's longest lifespans, start dying younger the moment fast food enters their communities? This isn't about DNA. This is about biology being switched on or off by the food you eat. And today, I'm going to show you exactly what Japanese people are eating every single morning that quietly reprograms how their body stores and burns fat. We're going to go deep into the peer-reviewed science, the actual mechanisms happening inside your cells, and I'm going to give you a precise 7-food protocol you can start using tomorrow. Stay until the end because the 7-day action plan I've built out is going to change how you eat breakfast forever. Let's get into it. Before we talk about Japan, I need to destroy a myth that the diet industry has been profiting off for 40 years. The myth is this: to lose weight, eat less, and move more. Now, is there truth in it? Sure, calories matter, but that framing is so incomplete that it's actually dangerous because it completely ignores why your body stores fat in the first place. Here's what's actually happening. Your body doesn't just passively accumulate fat the way a bucket fills with water. Fat storage is an active, regulated process. It's controlled by hormones, by gut bacteria, by inflammation, by the types of food you eat, not just the quantity. When your gut microbiome is disrupted, what scientists call dysbiosis, your intestinal lining becomes permeable. Bacterial toxins called lipopolysaccharides leak into your bloodstream. Your immune system responds with chronic, low-grade inflammation. That inflammation directly upregulates a fat-storing enzyme called lipoprotein lipase, particularly around your abdomen. In plain English, a broken gut literally tells your body to store more fat. And here's the kicker. No amount of calorie restriction fixes a broken microbiome. You can be eating 1,400 calories a day and still be in a fat-storing state if your gut is inflamed. This is the conversation Japan is having at a biological level, and America is still stuck counting calories. Now here's something that's going to challenge a lot of you watching. Japanese people eat white rice every single day, multiple times a day. White rice, which the low-carb community has basically declared a war crime, and yet 4.5% obesity rate. A 2020 analysis published in the Nutrition Journal looked at traditional diet patterns across 132 countries. They created something called a traditional Japanese diet score, measuring how closely populations adhered to traditional Japanese eating patterns. And the correlation between high diet scores and low obesity, low metabolic disease, and low cardiovascular mortality was extraordinarily strong. So what's the secret? It's not that carbs are good or bad. It's that the Japanese food matrix, the combination of fermented foods, fiber-rich vegetables, specific proteins, and how the meal is structured, fundamentally changes how those carbohydrates are processed. The rice isn't the variable. Everything around the rice is. And when you look at a traditional Japanese breakfast, what's called ichiju sansai, 1 soup, 3 sides, you start to see the biological genius of it. Every single component is doing something specific inside your body. Let me show you what. Your gut is home to approximately 38 trillion microorganisms, bacteria, fungi, viruses, archaea. That's more microbial cells than human cells in your entire body. And these organisms aren't just passengers. They are metabolically active participants in almost every process happening inside you. They produce short-chain fatty acids that regulate appetite hormones. They influence how much energy you extract from food. Two people can eat the same meal and absorb dramatically different caloric amounts depending on their microbiome composition. They signal to your brain through the gut-brain axis, affecting cravings, mood, and satiety. Here's what a healthy gut microbiome looks like in terms of fat metabolism. You have a diverse colony of beneficial bacteria: lactobacillus, bifidobacterium, Akkermansia muciniphila. These bacteria ferment dietary fiber into butyrate, a short-chain fatty acid that does three critical things. 1. It feeds and heals your intestinal lining, keeping it tight and preventing toxin leakage. 2. It activates receptors that stimulate the release of GLP-1 and PYY, your satiety hormones. These are the same hormones that drugs like Ozempic are trying to mimic artificially. 3. It suppresses a pathway called NF-kappa B, which is the master switch for inflammatory fat storage. Now, what does a broken gut look like? Low diversity. Overgrowth of gram-negative bacteria like firmicutes. A leaky gut wall flooding your bloodstream with inflammatory signals. Suppressed satiety hormones. Fat storage in overdrive, particularly visceral fat, which I'm going to talk about in just a moment. The average American gut, due to processed food, antibiotics, chronic stress, and low fiber intake, looks a lot closer to that broken model. The average Japanese gut, thanks to a lifetime of fermented foods and prebiotic fiber, looks a lot closer to the healthy model. That is the foundation of the whole conversation. Before I get into the specific mechanisms and the 7 foods, I need to make sure we're talking about the right type of fat, because not all fat is equal. Subcutaneous fat, the soft fat you can pinch under your skin, is metabolically relatively benign. It's uncomfortable, sure, but it's not the one that's going to give you a heart attack. Visceral fat is different. Visceral fat sits inside your abdominal cavity, wrapped around your liver, your pancreas, your intestines. It's not soft. It's dense, inflammatory, and metabolically hyperactive. It secretes something called adipokines, inflammatory signaling molecules. It floods your liver with fatty acids, driving insulin resistance. It's independently associated with type 2 diabetes, heart disease, stroke, dementia, and several cancers, regardless of your total body weight. You can be at a normal BMI and have dangerous levels of visceral fat. Doctors call this TOFI, thin outside, fat inside. It's more common than people realize, and the standard scale doesn't catch it. Here's why this matters for our conversation today. The Japanese foods we're about to cover have been specifically studied for their effect on visceral fat reduction. Not just weight loss, visceral fat, the dangerous kind. The mechanisms are specific, measurable, and documented in clinical research. Let me walk you through them. All right, this is the one the title of this video is about, and I promise, it earns the hype. Natto, fermented soybeans. If you've never tried it, it looks like beans covered in spider webs, smells like a gym locker, and has a sticky, mucilaginous texture that is an acquired taste. I'll be honest with you, the first time I tried natto, I questioned my life choices. But the science on this food is genuinely extraordinary. Let me show you why. Natto is produced through a fermentation process using a bacterium called Bacillus subtilis var. Natto. This fermentation does several things simultaneously that no other food in the Western diet replicates. First, nattokinase. Natto is the richest known dietary source of nattokinase, a fibrinolytic enzyme that dissolves blood clots and improves microcirculation. But more relevant to our conversation, nattokinase has been shown to improve the delivery of nutrients to metabolically active tissues and reduce the inflammatory burden on visceral fat depots. It's essentially a circulatory housekeeping enzyme. Second, PQQ and vitamin K2, MK7. Natto contains extraordinarily high concentrations of menaquinone 7, the most bioavailable form of vitamin K2. Why does that matter? MK7 activates a protein called osteocalcin, which has been shown in multiple studies to improve insulin sensitivity, directly combating one of the root causes of visceral fat accumulation. Now let's talk about the microbiome effect, because this is where it gets truly remarkable. A study published in the Journal of Molecular Nutrition and Food Research tested daily natto consumption on adults with elevated visceral fat. Over 12 weeks, participants who consumed 50 grams of natto daily, roughly 2 tablespoons, showed a statistically significant reduction in visceral fat area as measured by CT scan. But more importantly, the researchers measured gut microbiome composition before and after. The natto group showed significant enrichment of Akkermansia muciniphila, a bacterium that's become something of a superstar in metabolic research. Akkermansia literally feeds on and strengthens the gut lining mucus layer. Higher Akkermansia levels are associated with lower obesity risk, lower insulin resistance, and lower inflammatory markers. In other words, natto isn't just adding a good bacteria, it's remodeling the gut environment to favor fat burning over fat storing. A second study in the Journal of Functional Foods looked at the anti-obesity effects of Bacillus natto supplementation in participants with metabolic syndrome. The intervention group showed an 8.3% reduction in visceral fat area, significant improvement in fasting insulin, and reduction in inflammatory markers, IL-6 and TNF-alpha, over just 8 weeks. Now, I know what some of you are thinking. I'm not going to eat fermented beans for breakfast, and I hear you. But here's what I'll say. If you are willing to eat it, even a few times a week, the dose-response data is compelling. And I'll give you some practical ways to incorporate it in the protocol section. The practical dose. 50 grams, approximately 3 to 4 times per week minimum, daily if you can. Eat it cold. Heat destroys the nattokinase and the live bacterial cultures. Mechanism 2. And this one involves a metabolic phenomenon that most people have never heard of, but researchers are increasingly calling it the most underutilized weight loss lever in the human body. Brown adipose tissue, brown fat. Most of the fat in your body is white adipose tissue, white fat. It stores energy. That's essentially its only job. Brown fat is fundamentally different. Brown fat is packed with mitochondria, which is what gives it the darker color. And its primary function is not storage. It's thermogenesis, the generation of heat by burning calories. Brown fat activation essentially turns your fat tissue into a furnace. And the incredible thing is that most adults still have brown fat depots, primarily around the neck, collarbone, and along the spine. They just aren't being activated. In 1999, a landmark study at the University of Geneva, published in the American Journal of Clinical Nutrition, looked at the thermogenic effects of green tea extract. Participants who consumed green tea extract, standardized to a specific concentration of EGCG, epigallocatechin gallate, showed a 43% increase in 24-hour energy expenditure compared to the control group. That is extraordinary. And subsequent research has helped explain the mechanism. EGCG, the primary catechin in matcha, works through 2 synergistic pathways. Pathway 1, COMT inhibition. EGCG inhibits an enzyme called catechol O-methyltransferase, which breaks down norepinephrine, the hormone that activates brown fat thermogenesis. By slowing down norepinephrine degradation, EGCG effectively prolongs the brown fat burn signal. Pathway 2, AMPK activation. EGCG activates AMP-activated protein kinase, essentially the cell's energy sensor. When AMPK is activated, cells shift from fat storage mode to fat oxidation mode. Now, here's the critical distinction between matcha and regular green tea. Matcha is made from shade-grown tea leaves that are stone ground into a fine powder. Because you're consuming the entire leaf, not just an infusion, matcha delivers approximately 137 times more EGCG than brewed green tea. A 2021 systematic review in the journal Nutrients confirmed that regular green tea and matcha consumption is associated with significant reductions in body fat percentage and visceral fat specifically, and noted a dose-dependent relationship. There's also a temperature factor that most people miss. Brewing matcha above 80 degrees Celsius degrades EGCG by up to 30%. The traditional Japanese preparation at around 70 to 75 degrees Celsius preserves maximum catechin integrity. The practical dose: 2 to 3 grams of ceremonial-grade matcha brewed at 70 to 75 degrees Celsius, consumed in the morning, ideally 30 to 45 minutes before eating. This timing aligns with the AMPK activation window and maximizes thermogenic effect before your first meal. The third mechanism is about something most people are dramatically underestimating: the specific types of fiber in the Japanese diet and how they hijack your satiety system. Not all fiber is the same. The Japanese diet is exceptionally rich in several fiber types that Western diets almost never include. Fucoidins and alginate from seaweed, particularly wakame and kombu. These form highly viscous gels in the digestive tract that dramatically slow gastric emptying and glucose absorption. The result? A flatter blood sugar curve, reduced insulin response, and prolonged release of satiety hormones GLP-1 and PYY. These are the gut hormones I mentioned earlier, the natural versions of what expensive injections are trying to replicate. The Fukuoka Diabetes Registry, which followed over 4,300 patients, found that higher dietary fiber intake, particularly from fermentable and viscous sources, was associated with significantly lower fasting insulin levels and lower HbA1c. The researchers noted the protective effect was strongest for seaweed-derived fiber specifically. Beta-glucan from barley, the second major fiber source in traditional Japanese eating. Beta-glucan forms a thick gel that feeds bifidobacterium populations, returning us to the microbiome story. More bifidobacterium means more butyrate production, better gut lining integrity, less inflammatory signaling to fat cells. Prebiotic compounds from pickled vegetables, traditional Japanese pickles like nukazuki, made in rice bran beds, are not just probiotic, they contain live bacteria. They're also prebiotic, meaning they contain fibers that feed beneficial bacteria already in your gut. The combination of these three fiber types creates what I call a biological brake on overeating. You're not relying on willpower, you're not counting calories, your body's own hormonal satiety system is functioning the way it was designed to, because you're feeding it the substrates it needs. I want to pause here and ground everything we've talked about in concrete research. Because I know some of you are skeptical, and you should be. This is the internet, and there's a lot of noise. So let me walk you through 4 studies that, taken together, tell a very clear story. Study 1. Traditional Japanese Diet Score, 132 Country Analysis, Nutrition Journal, 2020. This was a massive epidemiological analysis that constructed a dietary adherence score based on the traditional Japanese diet across 132 countries. Higher traditional Japanese diet scores were independently and significantly associated with lower obesity rates, lower cardiovascular mortality, lower diabetes prevalence, and longer lifespan, even after controlling for physical activity, income, and healthcare access. The data wasn't subtle. It was one of the strongest diet-disease correlations in the literature. Study 2. Natto and Visceral Fat. Journal of Molecular Nutrition and Food Research. 50 grams of natto daily for 12 weeks. CT measured reduction in visceral fat. Enrichment of Akkermansia muciniphila. Improved insulin sensitivity. This was a controlled intervention, not just observational data. Study 3. Matcha Thermogenesis. University of Geneva, American Journal of Clinical Nutrition. The 43% increase in 24-hour energy expenditure. EGCG was prolonging norepinephrine activity through COMT inhibition, resulting in sustained brown fat activation throughout the day, not just a temporary spike. Study 4. Green tea and adipose browning. Systematic Review. Nutrients, 2021. This review analyzed 15 randomized controlled trials and found consistent evidence that EGCG consumption promotes the browning of white adipose tissue, meaning white fat cells are converting to a brown fat-like phenotype. This is an extraordinary finding. It means green tea catechins may be literally changing the character of your fat tissue from storage dominant to thermogenesis dominant. 4 studies. 4 independent lines of evidence, all pointing to the same conclusion. The biological machinery of the Japanese diet, fermented foods, specific fibers, specific catechins, changes how your body handles fat at a cellular level. This is not a trend. This is not a fad. This has been running as a natural experiment in Japan for centuries. All right, everything I've covered today lives or dies in implementation. So let me give you the exact 7-food protocol. Specific foods, specific doses, specific timing. Food 1. Natto, fermented soybeans. Dose, 50 grams, roughly 2 heaping tablespoons. Frequency, daily if possible, minimum 4 times per week. When? Morning, with your breakfast rice. Key rule, eat it cold. Never microwave. Heat destroys nattokinase and live cultures. Mix with a little soy sauce and mustard the traditional way and stir it as vigorously as you can. Stirring develops the sticky strings that carry the most active enzymes. Food 2. Matcha green tea. Dose, 2 to 3 grams, roughly 1 teaspoon of ceremonial grade powder. Frequency, daily. When? Morning, 30 to 45 minutes before your first meal. Key rule, water temperature 70 to 75 degrees Celsius. Use a thermometer or let boiling water cool for 5 to 7 minutes. And quality matters, ceremonial grade only. The bright green color tells you the EGCG is intact. Dull or yellowish matcha has already degraded. Food 3. Miso soup. Unpasteurized. Dose, 1 bowl, approximately 200 to 250 milliliters. Frequency, daily, traditionally at breakfast. Key rule, add miso paste after removing the broth from heat. Boiling kills the live cultures. Look for refrigerated miso marked unpasteurized or nama miso. Pasteurized, shelf-stable versions won't deliver the same microbiome benefit. Food 4. Seaweed, wakame or kombu. Dose, 5 to 10 grams dry weight. Frequency, 3 to 4 times per week. When? In your miso soup, in salads, or as a side. Key rule, don't exceed 10 grams daily. The iodine content is beneficial in moderate amounts, but can disrupt thyroid function at high doses. Food 5. Fatty fish, salmon, mackerel, or sardines. Dose: 120 to 150 gram serving. Frequency: 3 times per week minimum. Key rule: wild caught over farmed when possible for a higher omega-3 to omega-6 ratio. EPA and DHA directly reduce visceral fat inflammation through inhibition of the NF-kappa B pathway, synergistic with the butyrate we're generating from the fermented foods. Food 6. Pickled vegetables, nukazuke or tsukemono. Dose: 30 to 50 grams, a few tablespoons. Frequency: daily. When? Alongside breakfast or lunch. Key rule: naturally fermented only, not vinegar brine commercial pickles. Those are acidified, not fermented, and contain no live cultures. If traditional Japanese pickles aren't available to you, Korean kimchi is an excellent substitute. Same fermentation principle, same microbiome benefit. Food 7. Barley rice blend. Dose: 1 serving, approximately half a cup cooked. Frequency: daily. Ratio: 20 to 30% pearl barley mixed into your white rice before cooking. Key rule: rinse and soak the barley for 30 minutes before cooking to reduce phytic acid and improve mineral absorption. The reason we blend rather than go pure barley is that the combination moderates the glycemic impact of the rice while delivering beta-glucan fiber, without the digestive discomfort that large amounts of barley alone can cause. That is your complete protocol. 7 foods, specific doses, specific timing. You don't need all 7 every single day to see results, although daily adherence does show dose-dependent benefit in the research. Start with the 3 highest impact ones: natto, matcha, and miso. Those 3 alone will begin remodeling your gut microbiome within 2 to 4 weeks. Let me leave you with the core insight from everything we've covered today. The Japanese diet doesn't fight your body, it programs it. It feeds your gut bacteria the substrates they need to produce fat-burning signals. It activates thermogenic pathways that have been dormant. It restructures how you absorb food, how you feel full, and how your fat cells behave. 3 things I want you to do this week. 1. Add matcha to your morning routine. Start there. 2 to 3 grams at the right temperature. Do it tomorrow. 2. Find miso paste at an Asian grocery or health food store and make miso soup for 3 mornings this week. You'll spend 6 minutes total. 3. Try natto once, just once. If your first reaction is, "This is interesting," you're on your way. If it's absolutely not, try it in a rice bowl with strong soy sauce and green onion before you write it off completely. The gap between Japan and the United States isn't a mystery. The evidence is there, the protocols are documented, the biology is understood. The only question is whether you decide to use it. If this video gave you something useful, share it with one person. Leave a comment telling me which of these 7 foods you're starting with, and subscribe for more evidence-based content every week. No supplements, no sponsorships, just the science. I'll see you in the next one.